Hello, 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 everybody, and welcome back. It's Root Beer here. We're going to be starting Part B with question B1 of the Senior Math Contest, the Canadian Senior Paper, from the year 2016. Okay, so the thing that distinguishes Part B from Part A is that we have to do written solutions. We have to justify. So as you watch these videos, I will be adding in a few more sentences or making comments like, oh, I should have explained this a bit better, and things like that. Okay, so what have we got with question 1? By the way, in Part B there are only 3 questions. B3 typically the hardest question on the contest. But of course, it all depends on what you're familiar with, what math you're comfortable with. You know, if you're a big fan of circle geometry, and B3 is a circle geometry question, you might find B3 particularly easy, that sort of a thing. But we're focusing on B1 now. So, a positive integer that is the same when read forwards or backwards is called a palindrome. The same thing is true of sentences, you know, like rise to vote, sir. You can read it the same backwards and forwards. Okay, it's the same letters, just reverse order. Okay, but you know, numerically we're talking about palindromes. So 1001, 1111, 1221. Looks like we're talking about 4-digit ones. A table is created, as shown, in which the first column contains all palindromes between 1,000 and 10,000. So all 4-digit palindromes. And they're listed in increasing order. The second column contains the positive difference between each pair of consecutive palindromes. So the difference between 1,111 and 1,001 is 110. And it looks like it's the same difference most of the time. Maybe all the time. Okay, so, and then, for example, okay, they've got the example that I just read aloud. Okay, so that's what we're talking about. We're talking about 4-digit palindromes and their differences, I guess. So we've got 4 parts here. Now, for written questions like this, or on a Hypatia or a Euclid, you'll often find that they have multiple parts. You can approach these questions by just doing each part one after the other. This is how I'll probably handle this question, how I would handle questions on a Galois or early questions on a Hypatia. But harder questions on a contest, like Euclid's 9 and 10, Hypatia 4, you know, Galois 4 maybe, certainly the B3 on this paper, you want to try and read them all together, because you're often, the biggest challenge, at least with those hard questions, is the last part, you know, the C part or the D part, and being able to even get your brain working and thinking about that one before, even while you do A and B, can be quite valuable. Plus, you start to see a bigger picture. With those questions nowadays, it wasn't the case way back when, like 10, 20 years ago. But nowadays, what happens is the questions are carefully constructed so that A, very simple, very quick to do, usually a quick calculation. B, usually shows some result that leads into C. And if there's a D, the C part and the B part will lead in and go into there. And I think I just hit my microphone, so I have no idea what that sounded like. But you know, the questions tend to lead into each other, which, you know, that's why you want to sort of get this big picture and understand what's going on there. Okay, read it all at once. But, you know, this is B1, so let's just read it one at a time. So, what are the 8th and 9th palindromes in the first column of the table? So, we've got 1, 2, 3, 4, 5. I suppose we could just write these out. You know, continue on with our list here. We'll probably need more information on the list to do some of the more theoretical things, possibly in C or D. And even thinking that thought makes me want to go down and read B, C, and D. But, you know, we'll try and do this one at a time. So we'll get our notepad here. And I'm just going to I don't know why I wrote an R. Palindrome starts with a P. Palindromes, differences. So we have the first one here. I'm not going to write the one with a circle each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Even though I'm not actually saying things, completing the chart does count as a written explanation. Okay, 1, 2, 2, 1, 1, 3, 3, 1, 1441. You can notice a pattern here. The fifth one has 4s in the middle. The sixth one will have 5s in the middle. So the ninth one should have 8s in the middle. If you want to jump to something like that, by all means, just explain what you're going to do, and you'll be fine. While I'm at it, 110, 110, these two, 110. I don't want my differences chart to start going askew. But I'm noticing lots of 110s. To the point where I think it's only 110, and I'm wondering, why are they even bothering with this? But let's see where they're going. So, there's not a box to put your answer in, but, put a little box or put a little statement saying, oh, the 8th palindrome is 1771, the 9th palindrome is 1881. This question has 4 parts to it, and these questions, the B part questions, are worth 10 marks. At least in these years that we're going through. So you got to sort of judge what marks am I earning here. And it's probably 2 marks for A part, one for 1771, and another mark for 1881, or maybe a mark for both, and then 1 mark for a little bit of an explanation like a chart. But don't stress yourself out about A part when D part's probably worth 3 marks, C part's probably worth 3, and B is also probably worth 2. Okay? That's usually how the breakdown is. I don't remember exactly what the marking scheme breakdown was for this one. I don't think I marked this question that year. Anyway, so that's A. B. The second column of the table contains only 2 different numbers. They're telling me this. I don't need to prove it. 110 and X. Determine the value of X. Well, I'm seeing most 110s. And if we have a bit of a think, we might ask, well, where could another number arise? Well, why are these all 110s? Probably because the ones on the end aren't changing, but if they become not 9s, if they become 2s, we can get a different change. So I'm just going to complete my chart a bit more, because I suspect that we're going to go a little further. So the 9th one, I'm just going to list him again up here so that I can do the difference. The 10th one is going to be 1991. That's also a difference of 110, but the 11th one is 2002. What's the difference there? 2002 minus, there's a 1 there. Need to borrow a bunch of, it's 11. So 11 is the other value. I don't need to prove that there's only these 2. They're not asking me to. They're telling me that there's only 2. I'm just saying 11 is the other value. And for example, 11 is 2002 minus 1991. Again, this is a fine explanation. Completing more of your chart is likely a fine explanation. It shows where you got this 11. Okay? But 11 is what we care about. Alright, so we'll flip the page so that we have a bit more space. We still have C and D parts here to do. When the table is complete, there are n palindromes in the first table. Because we go all the way up to 10. So it's only 4-digit palindromes. So when the table is complete, there are n palindromes in the first column. What is the value of n? Fine. All right, so now we would probably start writing some things out. Our table consists of all 4-digit palindromes. They look like A, B, B, A, where A and B are digits. Okay? All of them look like something, 2 things in the middle, and something. And it's possible for A and B to both be the same digit. We've seen 1, 1, 1, 1. But this is how we make that. Every palindrome has to look like this. So this becomes sort of a counting problem. How many choices do we have for A? How many choices do we have for B? Are the choices for B dependent on the choices for A? Okay. So, we can't have a leading 0. So A can be any of the other 9 digits. 1 through 9. B can be any digit and is independent of A. So it could be 0 through 9. When would B depend on A? If there were more to the question, like we're counting up the palindromes, the 4-digit palindromes that also happen to be divisible by 3 or something like that, then our choice of digits A would impact our choices of digits B. And I've seen questions like that in the past. I think there was a Pascal I did a couple months ago that was something like that. Okay? But in this case, we're just getting palindromes. All the palindromes we can. We're not singling them out. So A's, B's, any of these choices are fine so long as A isn't 0. So we have 9 choices for A, 10 choices for B. Okay? So all we need to do to specify a palindrome is to pick an A and pick a B. And when we do that, since they're independent, they don't depend on each other, any A can be paired with any B, we multiply to get the final answer. Okay? Think about it like listing out all pairs. A is the first digit, and B is the second digit. We have 9 choices here, 10 choices here. You can list them all out if you want to, but it's going to be a giant waste. So 90 palindromes. And now I've shown that n is 90. Okay. So we have 90 palindromes in our list, and the list is organized in increasing order. And now D part. Determine the average of all the n-1 numbers in the second column. So we're going to add up all the differences, divide them by n-1, but now we know n-1 is 89. So we're going to figure out, all these differences, add them up, divide by 89. The question is, well, I don't want to write out 90, no idea what that was. I don't want to write out 90 palindromes. Okay, you don't want to write out 90 palindromes, let alone get all their differences. So we have to think about this. When are we going to get 110 as a difference? How many 110s are we going to get? When are we going to get 11, the other number that we determined from part B? And how many 11s are we going to get? Okay. So there are 89 differences. Okay. The differences are either of the form ACCA minus ABBA, where C is B plus 1, or it's going to be, what are we going to say, B00B minus A99A, where B is A plus 1. Okay, so it's either something like 2002 minus 1991, or it's something like 1881 minus 1771. Now, if in the first case, we'll just list all these guys out. He's A times 1001 plus C times 110 minus A times 1001. I'm using the digits, and I'm writing them as an actual expression I can calculate with, plus B times 110. And that's, so these guys are going to cancel out, and then we'll be left with C minus B times 110, but of course C minus B is 1, so this is 110. Okay, and then the B00B minus A99A's, well, similar sort of things. It'll be B times 1001 plus nothing minus A times 1001 plus 9 times 110. And so this will be B minus A 1001 minus 990 B minus A, of course, is 1. So this is 1001 minus 990, and that is 11. So those are our possibilities. This might also stand as a proof in B part, but I really think extending the chart just to find the 11 is fine. Okay. If you wanted to prove that these were the only two, you would have to sort of justify that these are the only two ways we can have differences of 4-digit palindromes. I don't think that really needs a lot of justification here. So we get the 110 and we get the 11, but more importantly, we now understand where these guys come from. Okay? There are 9 choices for A in the ABB, or sorry, the ACC minus ABB. ACCA minus ABBA. So this is just a counting problem again. Case. And 9 choices for B. 0 through 8. Since C must also be a digit. Right? I can't have B is 9, because then C would be 10. That's not a single digit. And we'd actually be talking about the B00B case at that point. Therefore, 89 differences, because 89 is 9 times 9, differences of 110. Now this should, because we know it's 89 differences in total, 81 differences being accounted for, the other 8 should be 11, but let's just briefly talk about this. There are 8 choices for A in the B00B minus A99A case. Specifically 0 to... Oh, not 0. We have to start with a 1. 1 through 8. Since 0 isn't allowed. And B must also be a digit. And that tells me, therefore, 8 differences of 11. And now we just put this information together. So that'll wrap up D quite nicely. The average is 81 times 110 plus 8 copies of 11 all over 89. I don't think we should be simplifying this to a decimal, because I certainly don't think the top is divisible by 89, because 89 is quite a big prime. But we'll get 8910 plus 88 all over 89. And that'll be 8998 over 89. I will just double check. I don't think this is has a nice integer answer. No, it's 101.101123. Just leave it like this. Leave it as a fraction because that is the more exact answer. Don't write it out as a decimal. Okay? I know that might be what we're used to from school, but do not write it out as a decimal because the fraction is the more exact answer, and in math we want a more exact answer. Okay? But there's our first written question. I've shown you all the work I'd be willing to put in for it. Up next will be B2, and then in the future B3, so stay tuned for all of that. Feel free to skip ahead if you're really looking for a challenge that is B3 or something like that. But either way, I will see you guys next time.